So hello, good afternoon. This is a video about the post-laboratory discussion on the assay of hydrogen peroxide or the permanganometry. So the process, again, as we recall, we measure 20 ml of water and transfer it on the Erlenmeyer flask, and then we measure 2 ml of H2O2 solution and add it to the Erlenmeyer flask. This is a process wherein gintimpla ta atan nga analyte. Our analyte here is the 2 ml H2O2 or the hydrogen peroxide. And then we add 20 ml of diluted sulfuric acid to maintain the hydrogen ion concentration. So acidic environment is needed to maintain a reasonable constant hydrogen ion concentration. So and then we titrate it with 1N of KMNO4 or the potassium permanganate. Oops. And then we have among the experiments, so I've asked you kung diin matiyag nyo ang naka-reach sa endpoint. And the one that reached the endpoint is here, the 36 ml. Kaya diba at an endpoint is faint pink. So, ang 30 ml, white pa siya, clear, transparent. And then sa 38 ml, ano na siya, ng daw fuchsia pink. And for the 44 ml, it's more dark. It's darker than the 38 ml one. So, here, the closest that we have is the 36 ml, which is faint pink. So, kung diin nag-una appear ang color, dila ka muna ma-stop. That means that's the endpoint. So, kung ibalikon ta ang aton nga experiment, di ba, ang endpoint, before mag-reach ang endpoint, gakatunaw, gakadula ang pigment sang potassium permanganate. And upon reaching the endpoint, after 3 drops, the last 3 drops, pag shake, naghimo siya faint pink. So, the first appearance of color will be the end point. And for those like the 38 ml and the 44 ml, this is what we know as over-titration. So, ging over-titrate siya. So, the analyte in our experiment is the 2 ml hydrogen peroxide, and our titrant is the 36 ml of 1N potassium permanganate. So the normality here is the 1N potassium permanganate, and the volume is 36 ml. For the volume of our analyte, that's 2 ml. Then, next one, this is our data. So, volume of the titrant consumed, 36 ml. Again, mabalik ta kay ang 36 ml, amo ni siya ang nagproduce ng faint pink. And then, we have the normality of the titrant. It is also included sa procedure. So, 1N, the KMNO4, and the volume of the analyte in the sample is 2 ml. And next up, for our calculations, ang aton i-calculate ang molecular weights ng aton analyte. So again, di ba, per element. So ang hydrogen, 1 iya atomic weight. I-multiply ta siya sa 2 na subscript. And then we have the oxygen, 16 iya nga molecular weight, iya atomic weight, and 2 man iya subscript, kay H2O2, resulting to 34 grams per mole. And to calculate the milligram MEQ of the analyte, milligram equivalent of the analyte, we have molecular weight divided by valence times 1,000. So, ang molecular weight, ginkuha ta ni siya kay para ma-use ta siya in computing the MEQ. So, ang MEQ, molecular weight divided by valence, which is 2, ang valence ng hydrogen peroxide, multiplied by 1,000. So, ang aton nga MEQ is 0.017 MEQ. And for the percentage of H2O2, percent purity, we have this since, di ba, I've mentioned it on our pre-laboratory discussion or pre-experiment discussion, the percentage weight over volume ang aton ginpili kay volume, liquid, ang aton nga gingamit. So, percentage weight over volume. Ang H2O2 in liquid form siya. So, the formula is ml multiplied by n times MEQ divided by the sample volume multiplied by 100. So, here, ang percentage of the analyte ang percent here refers to the analyte or the H2O2. The ml refers to the volume of the titrant. The N refers to the normality of the titrant. So, volume and normality of the titrant. Ang MEQ, amo lang na di ang iyan ni analyte. So, para hindi ka mo mag-confuse, ang first sa percent purity, ang first ni nga mga values, the ml and the n, para na siya sa titrant, kay first. And then, ang MEQ, kag ang sample volume, iya ka analyte. Second ni siya ang MEQ and ang sample volume, iya ka analyte. Milligram equivalent weight. And then, ilapat ta ang aton nga mga the data that we have gathered. So, di ba 36 ml ang aton nga titrant, amo to siya ang naka-reach sa endpoint. 0.1 normal or 0.1 n, iyan normality. And then the MEQ, it is what we have calculated here. So, wait lang. Ang aton MEQ, ari siya, MEQ, analyte, calculate ni siya pagkwata sang molecular weight. So here is the calculation of the MEQ. Again, MEQ is equal to the molecular weight divided by the valence times 1,000. So, amo na siya, guys. And then, we divide it by 2, which is the sample volume. Ang volume sang aton nga H2O2 is 2. Then, multiplied by 100, that's 3%. So, that's the calculation. So, simple calculation. All you have to do is to memorize kung pila ang percentage purity, kag memorize nyo ang formula. Basically, sa QC, you need to memorize the formulas, formula of MEQ, formula of normality, and formula of percentage purity. Pero ang gagwa gid sa board exam, usually MEQ normality. Kag ang MEQ kag ang normality. So, for the permanganometry is one of the techniques used in a quantitative analysis in chemistry. It is a redox titration and involves the use of permanganates and is used to measure the amount of analyte present in a known chemical sample. So, amount of analyte in unknown chemical samples. So it involves 2 steps, namely the titration of the analyte with potassium permanganate and then the standardization of potassium permanganate solution with standard sodium oxalate solution. So for ang potassium permanganate is also known as mineral chameleon. So sang Genchem, famous na ni si potassium permanganate is known as mineral chameleon sa Pharchem also. But the Condy's crystal is a new name, new siya sa akon. Condy's crystal and mineral chameleon ang other names ni potassium permanganate. The potassium permanganate is probably the most widely used of all volumetric oxidizing agent. It is a powerful oxidant or oxidizing agent. So, ang H2O2 reducing, ang potassium permanganate is an oxidizing agent and it is self-indicating. So, wala na ta nag-use indicator. So, general types of the redox analysis, we have permanganometry, potassium permanganate as standard solution. Primary standard is oxalic acid or the sodium oxalate. Since it is self-indicating, ang KMNO4, we do not use any indicator and the endpoint is faintly pink. So, ang assay niya, kung direct, gina-use ta hydrogen peroxide. So, sa aton, direct titration ang gamit ta. So, we use hydrogen peroxide. For indirect titration of permanganometry, we use cherry juice for malic acid, precipitated manganese dioxide, and titanium dioxide. So, and then for the residual, we have sodium nitrite. So, as early as now, post it, guys. I-post nyo na ang mga Permanganometry, kung ano iyang standard solution, ang primary standard, ang indicator, kag for direct, ano iyang mga analyte. So, for the analyte, ang guys, hydrogen peroxide. Kung direct, kung indirect, we have cherry juice and we have manganese dioxide and titanium dioxide. And for residual, we have sodium nitrite. So, that's for permanganometry. Remember this because it is included in during the reviews, compre, and of course sa board exam, I think. Pero sa amon, wala siya nagwa since the pinaka-common to is Manov. Wala kami mayo QC. Lucky me. So, luckily, wala kami QC gid. So, differentiate reducing and oxidizing agents. So, ang reducing agent substance that undergoes oxidation and causes the reduction of other agent. So, active metals such as sodium, magnesium, aluminum, and zinc. They are the electropositive elements or compounds. Ang oxidizing naman, substance that undergoes reduction and causes the oxidation of the other reagent. So, ang oxidizing agent, undergo siya reduction, causing oxidation of the other agent, while the reducing agent undergoes oxidation, resulting to reducing other agent. Bali, ang iya nga name, ga-refer or ga-reflect siya sa kung ano ang iya ginahimo sa other agent. So, like, for sa reducing agent, gina-reduce niya ang iya other agent, or here we have ang potassium permanganate, since atong reducing agent is the H2O2. So, aton nga yaging reduce is ang KMNO4. So, muna siya. Ang oxidizing agent na naman, compounds with unusually large oxidation states, such as the permanganate, chromate, and dichromate ions, as well as nitric acid, perchloric acid, and sulfuric acid. So they are electron-negative elements or compounds. And then the common uses of hydrogen peroxide. This is the agua oxygenada that we know, agua oxygenada. It acts as an oxidizing agent or reducing agent, just like in the experiment. So, we have kung 3% ang hydrogen peroxide, ginayo siya as antiseptic, kamo nasa sa wounds. Iya nga volume is 10 volume. Kung 6% ang hydrogen peroxide, ginayuse siya as bleaching agent. So, 20 volumes naman. So, it is important for you to remember the volumes of hydrogen peroxide because it is also part of the compre and the review. So, 3% 10 volumes, 6% 20 volumes, and ang 3% antiseptic, ang 6% bleaching. So, the common uses of hydrogen peroxide, food grade. Pag food grade, it is allowed to be ingested. Pag chemical grade, hindi siya pwede makaon and it is harmful. So, sa lab na siya ginagamit. Or lab grade na tawag nila. So, 35% hydrogen peroxide are used in mushrooms to combat molds. And the 90% for industrial use naman, or the lab grade that that I have mentioned, it is used as a cleaning agent. 90% na-use siya pampaninlo. Kaya again, bleach sa, diba? So, it has an oxidizing and reducing agent. So, in the experiment, is there any indicator used? So, wala ta indicator kay ang potassium permanganate, self-indicating. So, hindi na ta kinanglan mag-use sang indicator. So, that's the end of our discussion. Again, ang H2O2 is hydrogen peroxide, agua oxygenada, and I want you to remember the formula. Ang pinaka-importante lang di guys na mabalon nyo at the end of this experiment are the formulas. Magkuha molecular weight, of course, it's a given naman. I know you already know how to get the molecular weight, kaya add mo man lang na ila weight, but the hardest part here is to memorize. So, i-memorize nyo first ang CHO, since amo na siyang pinaka-common. CHO, carbon, hydrogen, and oxygen. carbon 12, hydrogen 1, and oxygen 16. And then, ma-add ka mo, sulfur, kay sa sulfuric acid, pinaka-common. And then, what else? CHO, potassium. Sodium din, hindi magid siya amo na. But the CHO is very important. So, it's important nga kabalo ka mo kung pila iya nga molecular weight because in the board exam, syempre, hindi na ka mo na pagpadalon sa mga tables and anything. So, dapat memorize nyo. And also, this the percentage purity para mabalaan kung pila ka percent ang analyte or pila ka percent ang H2O2 sa aton nga sample. And of course, the formula for normality and for MEQ also. Here, the MEQ, it is also important. Pag QC, MEQ, normality, that's the most important part, thing in QC. Tapos, the permanganometry, potassium permanganate, I want you to remember this. Potassium permanganate, oxalic acid, iya primary standard, iya indicator, wala. And then, for the sample assays, ang gina-assay or ang iya analyte, kung din siya gina-use. So, sa hydrogen peroxide, sa cherry juice, for the presence of malic acid, manganese dioxide, and for titanium dioxide. And for residual, sodium nitrite. So that's all, guys. Prepare for a quiz on Friday.